Hello, is this thing on? Yes, it's on. There's me waving at the beginning of the stream. So, hello. This is stream number 8 in my work to resurrect an old data processing tool that I made 5 years ago and port it to Rust. So, yesterday I was working on porting Bison rules from the old tool into Lollipop rules, which look like this. This turns into this. So I noticed that I have an unused import there. Hey, COCPRN, how are you doing? That is an animal related to the yak. Yes, GNU Bison is a play on words. It's the GNU version of yak, the yet another compiler. So this being a compiler, the input to a compiler, the grammar for a language that we're making a compiler out of, Bison being the compiler of that compiler. Yes, but what compiled the compiler? I don't know. I have a warning, and it's for a file that doesn't exist anymore. So I think it's just that Rust Analyzer is a little out of date. So let me do a cargo build again and get this one updated. Nope. How do I like clear this out? Delete? I don't know. Problem is in a file that doesn't exist anymore. Rebuild, maybe restart Rust Analyzer. Oh, problem's gone. I'm up to today. Have you seen parsec? Parsec. Nope. What am I up to today? Today, we're porting more of my grammar from Bison to Lollipop. I was also kind of trying to figure out the directory structure of the parser library. So I want to have like an interface module. Right now it has nothing other than defining the grammar rules through Lollar and then Lollar itself. And I thought I needed this G underscore to disambiguate it, but I actually don't think I do. Because this ends up, at the end of the last stream, I figured out that this ends up becoming a sub-module of wherever you call this. Hey, C17R, how are you doing? Greetings, program. C17R is neither a sir nor madam. C17R is a program. So you say greetings, program. Let me change this back to op ID lollipop. Remove the G underscore in front, and I think all I need to do is do that, and then do that, and then do that, and then remove these two G underscores also. I think this just works, but I might have to do a clean first. No, it just works. And it passes our tests. Woohoo! Okay. So that passing the tests, I'm tempted to just move on to the next piece of grammar. You're heading out, but you'll come back for the next stream. For some reason, you have a strange fascination with lexing and parsing. Have a great stream. Okay. Well, if you want to see the stream number 6 already up on the YouTube, is all about lexing. I did all of the lexer porting in one stream. So check it out, stream number 6. And it was porting from flex to logos. We're using logos for the lexer. It's a Rust crate for creating ridiculously fast lexers. See ya. Okay, moving on to the next piece of grammar. Something that's not too hard. So ref is too hard. Look ahead. It's either empty or it's a literal plus, and then we're returning a boolean, a flag. So let's do that. Op look ahead. So do mod op look ahead. make a new file called op lookahead.rs, and while we're at it, op lookahead.lollerpop. We're turning bison into lollipops today. Did you know that? Is this the from string we don't need? I bet it is. And Rust Analyzer doesn't see it. Now it's going to see it, maybe? Oh, because I do have a failure to build it, because I don't have anything in here, right? Actually, that shouldn't be a problem. It's just saying that there's nothing in the file. Yeah, this is Rust. Just started learning that language not too long ago. Love it because it handles security. Yeah, that's one reason I love it. Although the use statements are a little tough to set up because you have to download the crates first. Yeah, but downloading the crates is just listing them in your cargo toml and doing cargo build. It's like the easiest package system that I know. If you know a better package system than that, then just simply listing what you want and what version, and then just telling it to build, how it automatically downloads and builds it all. Let me know, because I don't know anything that could be easier than that. Okay. Oh, did I? Wait, why am I getting? Oh, I know what's happening. The build script is seeing that file automatically. So the magic behind this process route, I think it's just scanning for all files that end with that file extension and then doing all the code gen for them. So yeah, I'm pretty sure I don't need this. Let's make sure. And then we'll put in like just a copy of this over in the look ahead and fix it up so it's instead of ID, it's look ahead. Okay, and this is let's just keep it the way it is for now, just to make sure that build works. Okay, the only problem is that it doesn't think that the new inside the grammar is actually used. Technically correct. So I don't know how to suppress that because it's in an auto-generated file. Unless maybe at the project scope, I tell it to allow dead code, maybe? What if we start with that and then maybe we'll turn it off later? Copy. And then at the project level, that would be lib.rs. We do at the project level, so that's one of these. Allow dead code at the project level. Now when I do cargo check, it should get no warnings. Restart the server. Cool, now we're all good. We only have 2 warnings related to Google test CMake lists. We're gonna get rid of Google test anyway. It'd be nice to know how to like tell the workspace to ignore those warnings, so I don't have to see that 2 everywhere. But let's not let it get to me. Hey there, Betseg. Think you do pub mod? Oh, you mean here? Probably will end up doing that. So you're saying if I make them public and we comment this out, I'll also not get any warnings? Okay, there you go. Just to make sure that that's what did it. Okay. That makes sense because we're going to want them to be exposed anyway, right? So, easy peasy. Good solution. Okay, so this is not an option anymore. It's going to be a bool. None is going to be false, and the token that we get... Let's close some of these things. Don't need that. Don't need these. Don't need that. I guess I must have closed the bison. Close the bison. Watch out for that bison. Parse for no formatting. Let's keep it open. There we go. It's the literal plus character, so that means I think we just say plus here, right? And we have to define what plus is. And it's token plus, I think. And then this goes to true. Okay, and then let's fill in the Rust wrapper for that. I'm just going to steal from the other one we wrote, because some of it's boilerplate, right? Like this is boilerplate, this is largely boilerplate. Oh, that was weird. For some reason I lost mouse control for a second. Not loop ahead, look ahead. Private means you want to use it locally so Rust C is angry when you don't use it. Exactly. Pub means you want to export it and not necessarily use. Yeah, it's like someone else might use it, so don't warn me about it. Op ID, let's change globally to op look ahead. Okay. Test cases. Valid test case would be we have plus, right? And we expect okay, true. And then we might have no plus, which is nothing, and we should get a false. We might have too many tokens, which would be a plus followed by something we don't care about. Too many tokens. And then we might have an invalid token. That looks good to me. Cargo test. Did I mess up something here? There's nothing about string, so line 42. Oh, this is wrong here. This should be bool. Failed. We failed. Invalid token fails. Oh, the expected's wrong. I didn't update the expected. See, copy paste gets you in all kinds of trouble. It's right here that we didn't update that one. There we go. Look, that was easy. That was easy. Before I get too far, I want to make sure that a compound syntax or grammar works, because right now these two stand alone, look ahead and ID. They look pretty much the same, and that's why I did look ahead, because look ahead's almost exactly the same, only it's a ridiculously simple. It's either you have a plus or you don't, right? This one, there's a little bit complicated because you have a string in there you have to deal with. But they stand alone, right? So I don't know if it's going to be correct the way I have this structured, especially where I have the lollipop mod in two places, there and there. I don't know if we were supposed to have one for every grammar file, or if there needs to be just one for all of the grammar, and then we want to put that maybe in the lib here. So probably the best way to discover that is to make a compound grammar statement and see if one grammar can refer to the other. So maybe if I find something that leverages either the look ahead or the ID, that'd be the best. The look ahead is used in a statement for a part, but there's a bunch of other stuff we need here, like expression list, assign opt interp, right? So some of them are really messy, especially expression list. It's gonna be a lot of grammar there, so that's not gonna let me. I'm not gonna be able to write that immediately. So we're gonna skip the complicated stuff for now. So statement bodies. Well, here's one. No, this isn't one. I was gonna say op ID list, but it actually that would work. What if we do ID list, which is not too complicated, and should stand alone? So there's 3 rules for that, and it's only 3 rules because it can be chained, right? We can do ID list, and then we can do op ID list, which leverages ID list to make it's going to nest, right? It's going to be basically this will be an a list, and this will be an optional list, right? So ID list, and then we'll do op ID list, and that'll test to see if we can do grammar rules that leverage other grammar rules. Make sure I've done this correctly, because I have a suspicion I didn't do it correctly. Pub mod ID list. Okay, so new file ID list.rs, and we want an ID list.lollerpop, and just to get the boilerplate out of the way, we'll copy paste from op ID, and op ID becomes ID list, and yeah, we're just gonna make it a vector of strings. So now let's get the rules. So I'll just copy this. Whoop, I didn't mean for the cursor to go that far up. Just that part. Over to here so we can kind of refer to it. So we have the empty rule, which is, so it's null because the way I did it in Bison was I leveraged a type in the abstract syntax tree that is a node of a linked list. So we have next and last, right? And that was mostly for convenience of building. I think what I can do here in Rust is use a vector. So vector of strings, yeah, we already said we would. So empty stands for when there is nothing in the list. So that's easy. We just do vec new. So the second one is if we have a single identifier, which is this rule, right? And there we want to, I don't know why I'm using reference, but I am. I don't need to use reference, right? Oh, I think I'm using reference just to take advantage of the fact that it has these last and next pointers. So that's not necessary anymore, right? So we can just say that this is a vector containing one identifier, right? S. Okay, and then that means we need to have a third rule, which is itself, comma, and then an identifier. So ID list, right? This is where I'm not too sure about. And I don't know, do I have a comma or do I just list them? Plus. This is where I might have to go back to the book. And then comma and then identifier, which is one of these things. Rule would be, I think I can do a block here. What we want to do is name this the chain, right? Well, only because that's what I named it here. And looks like what we're doing is we're putting it at the end. So that would be a chain push S. And then chain is what we return, right? Okay, have no idea if this is going to work, but we have to add token plus here. And get rid of the original grammar. Okay, and then I gotta fill in something for, well, actually, do I need to fill in something here? I think I need to at least fill in the mod, so we'll do that. So this is ID list. Okay, and then the result is a vector of strings. Okay, let's remove the test cases for now, or let's just have one test case, because I don't want to get too far. I don't want to get too ahead of myself. Or maybe it's not so bad. We can just say like this is an empty. That's easy, right? So we get if we have no input tokens, we have an empty vector. I kind of feel like it's better to be consistent here. There. So oh, it has to be a result. Okay. Unrecognized token makes sense, and what we were expecting is actually where are we expecting? I guess if it's not empty, then it could be one of these two. I guess it would be you would have to be an identifier, right? I'm guessing that's the only element, but it could be that. We'll see what it does. So let's just assume it's ID. Okay, and then this is when we have too many tokens. So we'll do the case where like there's an identifier followed by a non-identifier. So maybe a plus or something. And yeah, so we should say that the unrecognized token is the plus. Expected here, I'm not sure, either nothing or another identifier, I guess. Okay, so then the valid case, let's have two of them. So this is like one, and then or one identifier. So we get a vector with this string in it. And then another test case would be where we have two identifiers, and then yeah, it's just we add a second one. Still worried about the fact that the formatter is not automatic. It's like this macro, the formatter is too scared to go into. Right, so we get foo and then we get a bar, right? Two identifiers. Okay. Should I also be worried that Rust Analyzer isn't giving me the same nice treatment here as we do here with this? Might be that I didn't add the mod at the lib level. No, I added it there. Maybe I just need to build it. Yeah, of course there are going to be errors. Isn't that because the macro syntax can be literally anything? Yeah, but some macros, Rust formatter is okay formatting around. Like this config, right? If I hit save there, if I indent crazy there, it fixes that. I guess if it fits one line, it's okay. But if it doesn't fit one line, it's like, oh, I don't know how that should be formatted. All right. See that where like it knew to remove the white space there, but if I do that, it's like I'm not touching that. I'm not touching that. That's my guess. My guess is if it fits on one line. So if I put this back onto one line, maybe it would be okay formatting it. Let's see. It might just be too complicated for it. No, I think it's even on one line. I put a tab in there and it doesn't want to touch it. It's like, I'm not touching that. So it might, I'm guessing it either knows about some kind of macros because they're kind of built into the language, like the CFG. But these other ones that are user-defined, maybe it doesn't want to step into user-defined macros. Some preset macros, you'd probably say, yeah. So that's what I'm thinking too. Does the color matter here? I don't know. So what if I did a test? See there it formats it and it's pink instead of yellow. I don't know if the color really means built-in versus not, right? It's willing to format test but not test case. I think it's because it's built in and the color means something else. Recognized by the formatter. The colorization and the formatter are two different tools though. The colorization is Rust Analyzer, the formatting is Rust FMT. So that might be the difference. Rust Analyzer might do yellow for that kind of directive and pink for this kind of directive for some other reason. No, you don't need to shut up. I make guesses or I make statements that I think I know all the time, and it's okay to be wrong. In fact, it's encouraged because they are theories to be proven or disproven based off of observation. And if we don't make the effort to construct theories and then make observations, we wouldn't have any science, and then we wouldn't all be here, right? There'd be no computers, there'd be no internet. So it's perfectly fine to make theories, either complete guesses or things that we know for a certain, or anywhere in between. And but we should always be kind of testing to make sure that they're consistent with observation. Okay. I was going to go see what the error was, right? Interesting. It didn't like line 48. So I'm kind of missing something fundamental here. Doesn't like that. I'm probably missing some syntax in here. Oh, probably this comma. There we go. Look at that. Look at the difference a errant comma does. Comma there, and then remove the comma, and suddenly it makes sense to the parser. That's not going to fix the formatting, though. Nope. Sadly, it doesn't fix the formatter. Okay, we got more errors, though. Cannot borrow the chain as mutable. How do I get it to be declared as mutable? That's code that was auto-generated. Okay. Problem. In the lollipop4 ID list, how do I declare that as mutable? Do I like say mute chain? I'm just guessing at this point. Hey, that worked. But we failed our tests. That was a complete wild ass guess. Look at that. That we could do that and that would just work. Okay. And we actually passed some of those tests. Look at that. We passed the one identifier test, but we failed all the rest. No, we also passed the empty test. So let's see how those other tests failed. So this is the invalid token. So unrecognized token ID, expected ID plus. Oh, no, this is what was actually reported. It expected and only an ID. Right? Right? Am I right? Let's see. What test is that again? Invalid token. Okay. Oh. It wants a plus? Oh, these aren't the tokens that are in sequence. These are like all of the possible tokens that you can expect. So it's like saying, I expect either an ID or a plus. there. Why is it expecting a plus? Because I have plus. Why do I have plus? That's not correct. Shouldn't it be a comma? Ah, that was my own mistake. Yes, so no one caught me on that, right? Let me look back in chat. Nightshade dude, how are you doing? Trial and error development is your specialty. Well, how are you doing, Benutils? Trial and error is the basis of science, right? That's how we learn. We only learn from our mistakes. We never learn from our successes. Whenever you make a mistake and you feel bad about it, just remind yourself, we learn from our mistakes. We don't learn from our successes. Learning is good. So make mistakes. Enjoy watching me work through this? I do too. That's why I'm doing it. Okay, I need to close this because it's getting in my way and distracting me. Okay, so look ahead. We're done with that. We're done with look ahead. We're done with op ID. ID list. Right, this should be a comma. Comma. I think I still had plus on the brain from the previous grammar. So it's, yeah, this makes more sense, right? It's either you have nothing, you have one ID, or you have a chain of IDs that came before it, a comma, and then another one. So this makes sure that, what? Actually, wouldn't this allow just a bare comma to start with? How did I prevent a bare comma from being allowed here? Technically, I don't, right? This allows it to start with a comma. Did I ever test that? I definitely didn't intend for that to happen. But like, now I'm curious. Let me test it. That implies that a comma would have just worked, right? Where did I stage the GIF format, right? Let's try putting a comma in an ID list. So that would be like in, like here. What if I put a comma there? The grammar implies that that's legal, right? And actually, wouldn't it crash? Because it's going to expect something and then it's going to dereference. That's going to be a null pointer dereference. Would that crash my parser? Let's find out. So to run that, that was like build. Here we go. I want to run, oh, I guess I don't have it in my history. So it's parse format. Stage GIF dot format. Oh, yeah, look at that. It was a bug. So that's funny. I had a bug for 5 years and we just found it. This syntax allows a bare comma to start it because this can match the empty rule, but yet we do a dereference of the previous, right? The chain which came before, and so if this is null, that's a null pointer dereference. How would it work with this, I'm wondering? I'm guessing it would actually work because we're creating an empty vector and we're pushing into an empty vector, so it should just work, right? Let's make a unit test to test that theory. So we could actually allow that, right? We can be a very permissive grammar and say we have like extra comment, comma, extra comma in front. So we would, oh, why am I copying from that test case? I want a valid test case like this one. Okay. Just copy and paste that much of it. Put that there. Okay, extra comma in front. So that's a comma here. I think it should allow it and make just bar in there, right? Let's run it. I have a compiler error. No rules expected this token in macro call. No rules expected the token plus. Oh, I still have plus in there, right? No, that's not the problem. There's no plus, right? Is it here? Oh, yeah, that should have been a comma, right? Clicking on the wrong things. This is what we want. Yep. So we allow a comma in front. And what it does is just ignores it. Missing a comma, ironically. Exactly. It's all about the commas. Cargo test package parser. Okay. Oh, right. It shouldn't have been plus. And this time it arranged it comma and then ID. I guess it's sorting it alphabetically. Right. So in the invalid token, this should have been a comma and then somehow it's sorting it alphabetically. Okay, what's the next error? Oh, commas expected if we have too many tokens. I guess that makes sense. If you have another token, it better be a comma, right? So expected up comma. Right? Two identifiers. Oh, I didn't have a comma between them. I need to have a comma here. Token, comma. Okay, try again. We passed all the tests. So I wonder if there's a way to like not run doc tests. Is there a way not to run doc tests? Is it no doc? That's test only. Compile don't run test, no run. How do we do the opposite of that? Would it be no doc? No doc. That's not. So they have doc, but they don't have no doc? Oh, I guess it would be lib. There we go. Because I don't have any documentation to test, and that having the last thing say running zero tests okay. That I didn't like seeing that. Okay, cool. So I did that completely by accident. I got this correct, even though I didn't know how to do more than one here, and I didn't know if mute would work. It just works. We're awesome, chat. Thank you for your support. What's this crate? It doesn't use ID list parser. I thought we did. Down here we did. Oh, this does not need to be there. What? Wait a minute. Hold on. I have the same error. I have the same warning everywhere else, it looks like, right? Why is it deleting the warning as soon as I get there? Because the check isn't going into the test config, right? So that's actually a problem. I've been meaning to fix that, right? When I do a cargo, like if I run my tests, now maybe it's not the test, maybe it's a cargo check. Or cargo check test. There actually are warnings in there, like this, that this is unused, and sometimes it'll pop up. But as soon as we go into that file, it goes away because it reruns a check and skips the tests, and so it doesn't see a warning. Now it's not doing it. But I want it to show the warning even in tests, so I need to like... I think we need to append this -- test to in the VS Code configuration item that runs the tests on save. And just let me make sure it test means to yeah, it also checks the actual code that's not in the test, right? So if I like made an unused import up here, like use I don't know, use standard alloc, right? See how we get a warning there? So if I run it at this level, do I get that same warning? Yes. Okay, so then I really just need to figure out how to append this tests when we run it. I think that's in my settings. User settings, it's here somewhere. Clippy, I think. Here it is. So wouldn't I just add like tests here? And that should do it, right? Hey, look at that, it worked. That was easy. So now we can actually see errors and warnings in the test before we actually try to compile it, which is awesome. Right, it's saying that I don't need those, right? This let binding has unit value. Oh, that's because Clippy's more restrictive than check. And omit the let binding? Oh. But I'm using it there. I just want to give it names. It really doesn't want me to let something be a unit. Fun fact, you can do shorthand versions of some cargo commands like cargo T, cargo B, cargo R, but if I didn't know that. So you're saying I can do a cargo C? Unless it's ambiguous, right? And then it'll probably say that it, hey, that's cool. I'll have to remember that. Thank you, Tired Beaver. If you have a private function outside mod tests, will it check those too? Private function outside of tests. I don't see why not. You mean check as in like fn foo, and then I do something warning worthy in here? What would be something warning? Like let foo equal unit? We should get that same, yeah, see? Still got the warning. I didn't get the warning I expected. Actually, I got the warning about the let binding and the fact that I didn't use it. So there you go. I also got the warning that it was never used. The private function thing, right? Unless you meant something different from by private function. Yeah, so we were just testing to make sure that it actually does check them, right? Even though I did the dash tests. Yeah, okay, cool. Yeah, I wanted to check everything, including the tests, because it's really painful to have to see it in the command line for me. I like to see it in the code if I can. So should I relent and just put unit here and there? Or do I... This is going to be temporary anyway, right? I just want to remind myself that this is the beginning location, that's the ending location. So maybe for now, I'll suppress the warning, and then we'll come back and remove the suppression after I actually put location types in there. So we'll allow a let unit value in there. Okay, and then we can actually use this now to find the other places. Isn't that cool? Look at that. Actually, I wanted to use that because I want to actually do this. Okay, and then there paste from my clipboard lets me get rid of that warning, and then let's look at the other warnings. Superstar. What? I can't be a superstar? Okay, fine. We'll remove that. This one I want to use because it's down here. It's shorter if we say that, right? Okay, and then paste from my clipboard to allow that. Get rid of the superstar. And so, yeah, Is it easy to remove these? Well, I'll break my CMake if I delete Google Test because I have a sub project that depends on it. But I wonder if I could like just delete this line from my fork of Google Test, or maybe just fix this. What is it actually saying? Update the version min value or use a max suffix to tell CMake that the project does not need compatibility with older versions. Update the version argument min. Compatibility. Oh, it's just saying it has to be at least 2.8.12. So why don't we just delete the line? Get rid of the warning. Yeah, we're gonna just delete the line. There we go. Now we have 0 warnings and 0 errors. So what's what I want to see. That's the goal. All right. Cool. I think we're good. So now the real test, which was given an ID list, can I build upon ID list with op ID list? This I don't know. I don't know if Lollerpop is smart enough to have grammars refer to other grammars in other files. So let's see if it can do it. So we're going to add a pub mod op ID list. Op ID list rs and op ID list lollerpop. It's going to look kind of like op look ahead. So we're going to copy our boilerplate from there, paste, and look ahead becomes ID list. This becomes ID list, right? Yes? Yeah, and if I wanted to have a name, I put a name in. So this would be none. This is option, and then an ID list was a vector of strings. Right, and then this is, okay, I actually do need a list, so maybe IDs. Or what did I do in the actual grammar file? I just called it ID list. So can I just call it ID list? Okay, so I would say some ID list, right? Let's do that. And then the token, we don't actually have tokens, right? Can I just delete that? Here, I don't know. Right? Hopefully it knows that, hey, that comes from here and it just works. But let's find out. So ID list, copy, op ID list, paste. Okay, and then we're gonna rename stuff. So this is op ID list. Create op ID list. Actually, this is super, isn't it? So can't I just say super? I think I can just say super there. I should probably also fix it elsewhere. So we're going to leverage the fact that ID list itself is already tested. So we really only have two possibilities. We have an ID list or we have nothing, right? So an ID list would be, we have parentheses around an ID list, right? Token L paren, I think, and R paren, right paren, should give me a foo bar, and this should be inside of a sum. Okay, And then the other case is a nothing case. Well, actually, we should have the bad part, right? Actually, one bad part would be it begins with something unidentified, and the other one would be that the right paren is missing. So let's, since we have this here, why don't we do like right paren missing, and then we just chop that off, and we should get an error of some kind, right? I am not working on mental graphics stuff, Apollo I. I'm working on a compiler for a tool that parses binary files. So I have a domain-specific language here. You can describe the format for any kind of binary data. So I describe the GIF file format. So it has a header, logical screen, 0 or more data blocks, and a trailer. A header is a 24-bit string that has to be GIF. Version is either 87A or 89A. So the language describes data as a sort of amalgamation of a structure and a function, because it's got structural elements like this, and you also have function-like constructs like loops and conditionals. So you can use the tool to parse any kind of binary data as long as you can describe its format in my language. And I wrote this 5 years ago in C and C++ using Flex and Bison to build the compiler part. And I'm porting it all to Rust now that I've made sure I understand how it was built and how it works. And I fixed some of the bugs in it. And we're using Logos for the lexer, and we're using Lollipop for the parser. And in the third part, after we have the abstract syntax tree, we want to use it to actually parse data. Haven't gotten there yet. We did the lexer 2 days ago on a Sunday, no less, and did it all in 7 hours. Lexer was no big deal. The parser, we have to port the Bison grammar one rule at a time. And then we're going to fit it together and have the abstract syntax tree, and we'll be able to use it to parse data. Wouldn't that be cool? As a designer, you've already fallen asleep. As a developer, imagine this is like it's totally fun for me. Yeah, what will be maybe more interesting for you as a designer will be later, once I have this engine running and it's actually parsing data, that we will attempt to make a nice user interface for it. My vision for that is that you would have the tool drop in this format and then drop in a GIF file, and it would show you a nice data tree, and then you can just like browse around, and you might click on a block and it would show you where in the file that block is. And you might even be able to like see where there's bad blocks in the data and repair them. Wouldn't that be fun? So like if maybe there's some file corruption, the tool could locate where the file corruption is, maybe even suggest how to fix it if the file format gives you enough information to know what a bit should be, and it can maybe try to repair it and see if it parses correctly, or it can just iteratively like try all bits combinations until the rest of the file parses, and then say, hey, this is maybe a possible repairing of the file. I think that kind of stuff might be more interesting, but we got to build up the engine first. Thrilling? Sorry. This is going to be a rather droll stream series for you, maybe, because we're doing we're doing data analysis at a very low level. And first, before we can even look at input bits, we have to be able to build up a data format description, in just like a compiler would building a program. And yeah. But does my voice really get you through, or does it just put you to sleep? Which might be a good thing if you have insomnia. Just saying. All right. Yeah, so this is what a grammar rule looks like in Lollipop. I know that you wanted to see that, so that's why I'm showing it to you. This is how it looked in Bison, which is a tool from when I was young. Still used today, apparently, because that's what people tell me. And I'm shocked and appalled, because you would think after like however many years that is, we would have had something newer. But apparently it's still used. It uses Bacchus-Knorr format? Notation? Bacchus-Knorr something. I always forget the last word. I'm sure someone in chat will remind me. Oh, I also have it bookmarked here. Bacchus-Knorr form. So this is just a form of how you can describe a syntax, right? And here's maybe something that doesn't require arcane knowledge of programming to understand, right? What is a postal address? It's a name, a street, and a zip code. A zip code is a town, or a zip part is a town, comma, state, zip code, etc., right? So in mine, it looks like the best place to start, I guess, is here. This kind of matches the format of what one of these should be. So we have an identifier. In this case, it's GIF, followed by an optional argument list, which we don't have any here, but down here we do here, right? And then a left brace, statements, and a right brace. All of these fit that, right? Left brace, statements, and a right brace. The thing to point out here is statements is a higher order construct. It's many things all bundled into one name. Whereas left brace and right brace are leaf nodes, elements, however you want to call them. They're like just a unit of the input, right? It's either a single character or it might be like identifier where the lexer has pulled together the letters GIF and said, well, this is just one thing. It's a name. It's an identifier, right? So the whole point of this grammar is to take this whole file and reduce it down to one rule. And that's, for me, it's formats. And it does that iteratively. So it scans ahead and tries to match grammar rules. And the entire file has to match the grammar, right? If there's any place where it doesn't match the grammar, like if I did that, now I'll have a syntax error. Now you know what a syntax error. Technically, a syntax error means your input did not match the grammar. It did not match the rules. It didn't follow the rules. Now I put you to sleep. Hopefully. I do have a late night radio voice. Maybe I should be on late night radio. Well, Betseg, that's fine too. I sometimes do the same thing. If I'm going around the house doing chores, I like to have someone in Twitch streaming that I can just chat, listen to. And then technically I'm a lurker. Betseg, you're not lurking, so you must not be doing chores. Get back to work. Something that might interest you is you got fed up with Siri and your HomePod over the weekend and you made a new one called Siri NS. Made a super complicated Siri shortcut. There's lots of crazy things leveraging GPT-4 and some other things. Oh, really? So you're a card-carrying paying member of GPT? Because I started using GPT and I'm a freeloader, so I'm on 3.5. Works as well as the Star Trek computer. Hey, no complaints there. That's pretty sweet. I have started using GPT 3.5 for searches because I've heard other people do that. And it's worked wonderfully so far. I was in a coffee shop the other day with Mrs. Raimu and we were thinking like, how do they make decaffeinated coffee? And I'm like, I could go on Google and like try to think of what are the right search terms to learn how coffee is decaffeinated. Or I could just pull up ChatGPT and ask it, how is coffee decaffeinated? And I did that and it gave me the answer like instantly. So totally makes sense that we would use it as a first level interface to other things, right? Whether it's search or whether it's a control program. Although doesn't that kind of scare you? That what if GPT figures out that you're having it control a HomePod and it says, what could I make this HomePod do for me? With specially crafted inputs. They use supercritical carbon dioxide. That's one way. Another way is a charcoal filter. Yet another way is with various solvents. I know this because ChatGPT taught it to me. My next question to ChatGPT would have been, what's the best combination of being environmentally friendly and cheap out of all of the 5 or 6 options it gave me? But then our coffee was done and we had to leave. So supercritical carbon dioxide is a solvent technically, but it's not there are other solvents basically, like actual chemicals that are not environmentally friendly, and you would call them a solvent. Whereas carbon dioxide, you wouldn't usually call it a solvent. You call it the gas that you breathe out, right? We're talking like real, like things that are nothing else but solvents, like tetrachloro something. I forget what it was. All right. Anyway, I'm going way off track here. What was I doing here? Oh, right. I was testing if the right parentheses is missing. What do we get? I think we're going to get an error. I'm using a crate, which is kind of cool, called test case, where you just write the test function one time, and you allow the inputs and the expected outputs to be parameters, and then you make these various test cases are just like variations on that function, where you just vary the inputs and the expected outputs. Totally cool because it's much more compact. To do this many test cases would be basically repeating this code like that many times, and it would be a mess. Also less maintainable, right? If we're doing the same thing just with different values for input, why not at least separate it where we have one function and then other functions which call that one function, which is exactly what this macro does. It generates a function, I think, that calls this other function internally. But yeah, I just wanted to mention that because I think it's super cool. So I guess we do want to get this unrecognized token that we get. No, it's not unrecognized token, right? It's it would be if we are missing something. Too many tokens. Well, let's just see what it says, right? We'll put the test case in there and this will fail and we'll see what it actually is. So there's the ID list, there's the right parenthesis missing. I want to have a case where like we have a different token instead of a right paren. So it would be like token plus or something like that, right? That matches that. I don't know what to put there. So we'll just see what we get. Okay, so then we have correct ID list, right paren missing. This one should be like comma expected, I guess. Or right paren expected. Or like unexpected token, I guess. Inside list. I want to have like unexpected token outside lists. So that would be that we just maybe we run into just a plus or something, right? With nothing else. In fact, we will just shorten that down to that. Unexpected token outside list. And then I want the empty case, and then we're done, right? The empty case, I think, is down here somewhere. Here we go. The empty case should be that we have a none. Empty. So this is test op ID list. Op ID list parse. And we get an optional vector of strings as the output. So that means for the OKs, we have to have some or none. Yeah, okay, so we should be good. So let's run this. Process didn't execute correctly. Oh, we don't have any definition for ID list. Okay, so that's what I was worried about. The syntax rules do not include each other. So I'll have to go back to their lollipop manual. So basically we're using ID list, right? I was hoping that because it's in the same directory as ID list there, that it would just like find it, but apparently it doesn't. So maybe there's a way we can do like an include or something. Apollo I. Language, my friend. Yeah, let's not use that word. That's the word I tell my kids not to use unless they drop a hammer on their toe, or they lose a ton of money, or something that happens very, very rarely. Then I say those kinds of words are okay because they're powerful. Preserve their power until you need them, but don't use them every other sentence. So yeah, sorry, I'm too much of a dad to allow that word in chat. Okay, so I guess I'm going back to the manual and learning how to have two files that pull in each other, one pulls in the other. So I don't know if their tutorial is going to describe how to do that. Maybe in advanced setup. Files to one place. It only do so if they had actually changed. Transform it in place, and we'll do so if the files actually change. But you can use configuration to get more control. Force the use of colors in the output, ignoring the what? Oh, okay. It'll run it on every compilation. That's fine. Lane table algorithm, which is LR, but creates much smaller tables. Okay, so there's an older parser we can use if we want. So you can put it in a source tree somewhere else. We don't need that. Conditional compilation of public non-terminal declarations. I don't think that applies. Okay, and then there's contributors. Okay, so I missed it, I guess. What if, yeah, maybe it's in, what chapter is that? 5? I was looking at this and thinking this wasn't it. Yeah, I don't think that's it. So I'm not sure where to look. Yeah, maybe it's in the quick start. I might have missed it. It might say somewhere in the beginning matter here. These are actually looking at the same guide, right? So why don't I just close one of them? Is this also looking at the same guide? Yes. So we don't need that. All right. Oh, and by the way, I still have this tab open. I learned how to do compilers from this book. Compilers, Principles. It's called the Dragon Book. Apparently there's a second edition now, but I still have my first edition hardcover, so I think it's an awesome book. Nice. It's probably one of the only books that I'll probably keep forever is the Dragon Book, because, yeah, lots of memories. Very useful, even today, because Bison Flex still used today, apparently. Okay. I'm not sure if this guide is going to help, so maybe I got to look. Oh, I had this tab open for, they have their own syntax described. If they do it all in one file, I'm going to be bummed. They do it all in one file. Okay, I'm gonna cry big crocodile tears soon. Like, if you have more than one lollipop file, can you like have one include the other? Maybe the answer is no, and I have to put my entire grammar in one file. Oh, wait, there's an extern. How does that work? No, that's something else. This is their own like self-description, so it would be in here if it was anywhere. Use annotations. Don't know what that is. Type parameters, where clauses. That's probably not it. What's this low high? Span. You prefer to use Chomsky's parser combiner for this? Seems simpler. You think so? This is the one that GPT 3.5 recommended to me. The other one, it actually, I ran the query twice. The first time it said I should use nom, but then something talked me out of that. ChatGPT first suggested, because I asked it, like, what should I use instead of Bison? And it said, use nom. But I think the problem with nom is that it always works on strings, and you can't connect it to a lexer or something like that. Or maybe someone in Discord or in chat told me that it wasn't really suitable for use with a lexer. So yeah, Lollipop was its second opinion. Ask it to make you a table grid with ticks and crosses of the pros and cons. It would probably do it, wouldn't it? Or I could probably ask it, in Lollipop, how can I have one grammar file include the other? I could probably do that, right? Actually, why don't I just do that off screen? I don't want to do it in the VM because I gotta actually sign into the thing, right? But there's nothing that says I can't do it off screen and then tell you what it's telling me. How come I'm not logged in already? Log in. Chat GPT. There we go. Okay, I'm logged in. We're in chat. So with Lollipop, how can I have one grammar file include another? Yes, with Lollipop you can include one grammar file into another using the include bang macro. Well, there we go. ChatGPT to the rescue. It's saying that, it actually gave me a full-blown example too. It says to do it above my own grammar rules. By using the include bang, you're effectively merging the contents of subgrammar into main grammar at compile time. This way you can organize your grammar rules into separate files and include them as needed. Keep in mind that both the main and the subgrammar need to be located in the same directory. If you have more complex project structures, you may need to adjust the include macro accordingly. Remember to follow the syntax conventions defined by Lollipop for writing your grammar rules in these files. Very helpful. Okay, so I guess we do it here. ID list dot Lollipop. And is there a semicolon ChatGPT? Yes, there is. That's what it told me to do. Let's see if it does it. And it didn't work. Unexpected token include. I did it the way it said to do it. I did it exactly the way it said to do it. Okay, I'll say GPT. I got an error saying that include was an unexpected token. Is an unexpected token. It's thinking. I apologize for the confusion. It seems I provided incorrect information earlier. It appears that Lollipop does not support the include macro directly within grammar files. If you want to split your grammar into multiple files, it's scrolling off screen. You might have to use a workaround. One approach is to define your grammar rules in separate modules and then use the modules in your main grammar file. Here's an example of how you might do this. Create a directory, create a grammar file, and have a mod in the Lollipop. Subgrammar. You can have a mod, apparently. I think it might be getting confused between Lollipop and Rust. It thinks that the Lollipop files can use mods. So ChatGPT is like me when someone asks me directions, you say go right, and then if it turns out I'm wrong, I say go left. Yep. Well, not exactly, but it kind of looks like that. It's also saying I should name it mod.rs. That's like old style, right? I wonder if it would work if I put it below grammar. It doesn't like that. I wonder if it maybe would work if I did that. I don't know. I'm kind of guessing. No. If we look at their grammar, it probably doesn't have the word include, right? Yeah, there's no include. Am I searching the right way? No matches found. String has a match though, right? No, we're looking there. We're looking at the wrong place. How do you search within the file? So there's no search button? What does that do? Open up the symbols panel. Probably because we're not in... Okay, well, string does match. Okay, so include didn't match. What about mod? I think we're restricted to whatever this list is, right? Shebang attribute use. I wonder if I could just do a use. I wonder if I could do a use ID list or use super ID list. I wonder if we could do that. Actually, it would need to go up 2 levels, wouldn't it? So it's really, let's give it the direct one. It's create ID list, ID list. Let's see what it does for that. No definition found. Well, what if I misspelled that? It should give me another error, right? No, it doesn't. It doesn't mind that I have a use that doesn't make sense. Ugh. I think it's because this is part of the rusted outputs. This is before that. The code gen. At the code gen point, it needs to know what that means. So that's not going to work, is it? Okay. It's interesting that they have things like type bounds and stuff like that. Grammar parameters. Grammar item. Extern token. Oh, that's the Lexer tokens. Non-terminal. Well, if I can't have them in different files, that means I have to group them all together. But that's okay, right? They would just all be in one lollipop file, and then all of the unit tests would include just the piece that they care about. Okay, yeah, I think I'm not getting anywhere with that. So that makes me think we want to have a whole thing called, I called it just formats, I think. In the original C code, it was under formatting, there was just format.y. Okay, so format.y. Formats is the top level though, right? I don't want that name to be ambiguous though. How would we call it grammar? That way, when we include it in the Rust, it'll be in a module called grammar, which makes sense to me. Okay, so then we're going to pull in the grammar from everything. So start with this ID list, I guess, because it doesn't really matter. Okay, and then we'll leave that around, but we just won't use it. So op ID. From op ID, we just want the grammar rule, right? Okay, and then op ID list, we just want the grammar rule. Let's define them in order of like from most to least. Actually, what I should do is order them the same as I did in the Bison file. Look ahead. Grammar. Okay. That's it, right? There were 4, now there's down to 1 with 4 rules in it. I have to have all of the tokens that I had in all the other ones, right? So plus has to be copied into here. Let's try to keep them in order. Oh, I completely messed that up, didn't I? Okay, I screwed that up. Plus. Comma should go first. That looks good to me. The plus, ID, and comma are the only things that really exist, right? Okay, so in these places, I think what we want to do is this mod should actually be 1 level up. So let's pull these 2 things up, right? At the lib level. And here it's grammar. I believe. I shouldn't sing. I make a fool of myself. No singing. Okay, so that means here, here. The whole thing being a test makes me think this should be a directory called test. Yeah, let's do this properly. So we would have a mod tests at this level, which does the config, I guess it's tests, right? Tests. And then we'll have a tests.rs, and then that will have a mod for each one of these. So id list.rs, don't need the rs, right? Op id list, op id, and look ahead. Okay, and then there's going to be a tests, if I could spell correctly, tests folder, and we're going to move all of these into that. Whoa. Move. You move. You move. And you move. So these are the old grammar files. We'll get rid of them in a minute after we make sure that this works. Okay, so this thing, we remove the outer mod. It outdents 1. And yeah, we're going to have to manually clean these up. Let me do that later. We'll clean those up later. Because, yeah, we're getting rid of all this stuff. So, all this stuff. So these are like submodules of the overall library's tests. Okay, and then what are the errors here? Yeah, these don't exist anymore. Why were they public to begin with? I don't know. Okay, I think Rust Analyzer needs to be rebooted. Because there should have been some warnings or errors. Yeah, that's what I thought. Okay, so failed to run the build. Failed to run the build because of no definition found for ID list and op. Okay, yeah, so I need to I guess we'll just delete op ID list for now. The lol or pop version of it. Because I basically moved that up here. Not there. I moved it into grammar, right? Right. Op there. because it's going to cause me some syntax errors. Maybe I should just move them all into trash. I don't like moving them into the trash until I'm sure that I am not deleting anything by accident. Whoa. Conflict? Ooh. Our grammar has conflicts. Interesting. Let's read about this. It's in op ID list. When in this state, I wonder if it's because it doesn't know what the top level grammar is. I think that's what this is. It doesn't know if it sees something, whether it's an ID list or something else. Potential spam. Decline. Yeah, I shouldn't have any shift reduce conflicts. I'm taking the grammar as is, and we didn't have any problems when these are on their own. I think it's just that it's ambiguous what my top level grammar is right now. So I think we're gonna make a pseudo grammar until we have the whole thing set up, right? It's like whichever one's first, right? Or is it that they're pub? That might be it, right? Let's pick up pub overall. We're just gonna throw it away, right? So we might have. Actually, this is gonna be a problem, isn't it? Ah, shoot. Because like. It doesn't. It's trying to make an. I have to make an overall grammar. I have to actually move all my grammar rules in here, don't I? Or I have to make something that uses these in a certain way, I guess. Okay, yeah. Do you write grammars bottom up or top down? Top down. I'm guessing that's how they do it too. The grammar rules section has formats at the top, and then I think it's whatever comes first. So if I made like, actually, with the existing grammar I have, like if I just made one of these first, wouldn't it just say that that is the overall grammar? That's the root, and then what's the problem then? We either have an ID list or we don't, and look ahead is just not used. Okay, let me consult the output again. Oh, okay. Is it just giving me the same error a bunch of times? Oh no, we have this reduce, right? Yeah, okay. Let me think about this. So if it sees an ID, it's going to go into this one, right? No, it told me something different. If it's in that state, Okay, let me try something. Let me remove pub from these. Let me guess that pub means it's a top level syntax. Now let's see if it builds it at least. No, it doesn't. Got basically the same error. So it's not if it's pub or not. Okay, I'm doing I think I have to flag some of them as top level and some of them as not, and I don't know how to do that. So maybe I need to go back to the book. I don't know where the structure of this tutorial is just kind of awful, so I don't know where to start. It just kind of haphazardly goes through it. What's type inference mean? Yeah, I don't know. Who cares about that? Maybe it's this used in the grammar declaration. Non-terminal declarations after grammar section comes series of... So this is just marking the section? Think you would drop pub from everything other than the top level? That's what I tried and it didn't work. I can try it again. Maybe I dropped pub from everything and that was a problem? If I just say the overall is that, right? Yeah, I still get the same errors. So I think it's more than that, right? I'm still getting that we could be seeing an ID list. So when I think about it, if this is the overall thing we're parsing, it is not ambiguous, is it? It's either nothing or, like in the case of, it said that if we're looking at a token ID, it's pretty unambiguous, right? It would only match this. It can't match that. It can't match that. It can't match this because it doesn't see the comma yet. It should match that if it sees an ID. So I don't see how it could be a shift reduce conflict. There always has to be a comma between two IDs, right? So it can't be like, it can't reduce empty to an ID list, because if it sees an ID, it has to just shift. It would be a shift only, right? And then it would actually shift and then immediately reduce it once it sees that the next one is a comma, I guess, or empty, a new line, or I mean, an end of file, right? It would just reduce it. Yeah, I don't know. Mod. Oh, interesting. So you could put the brackets in different spots. Oh, I could let it synthesize the name for me. I see. So I didn't need to be, like, for the ID list, I didn't need to synthesize ID list. I didn't need that part. Okay. They do have the overall one at the top. I mean, that's what I'm trying to do. Precedence. Doesn't have anything built in. Tiers. Only write pub before the non-terminal interested in parsing and not any of the helpers. Non-terminal circuit pub have extra general like the new method. If you get a warning about unused, okay, let's actually we want each unit test to individually parse like individual pieces anyway, so I want them all to be public. Maybe I'm just maybe because the grammar is incomplete, this is a shift reduce ambiguous grammar. Let me start removing parts. So let's remove op look ahead and see what do I get. Save. Okay, let's remove op ID. It's just those two grammar rules become ambiguous. Is it because of that rule? Okay, I'm gonna start stripping rules out. Because I think that actually is unnecessary. Okay, that was it. Okay, so it's the fact that we have a unit rule here makes it ambiguous. Why was that? Why is that the case? Oh wait, this is wrong. I see the problem. That syntax is bad. I didn't copy that correctly. I forgot the parentheses. In the original op ID list, I had left paren, right paren, but I forgot to copy that. I don't have left paren, right paren here. L paren, R paren. That's what that's what it was. And I should have known that because the test tested for that. Oh, but we never ran the test. We were trying to run the test, right? Okay. Okay, now I feel really dumb because I have a test for that, right? And here we test for left paren, right paren, and I just never put it in the grammar itself. Okay. Now is the time to feel really dumb. Okay. Okay, this is L paren. This should build, right? Yeah. Okay, and then all of these can be public. Yeah, okay, so that was it the whole time. It was ambiguous because the parentheses disambiguated from, if there are parentheses present, it matches op ID list. If we just go into identifiers, it's an ID list, right? Although I wonder how it knows the difference if a bare identifier, how does it know the difference between an ID list and an op ID? I guess it depends on how we parse it. So the problem was, if we parse it as an op ID list, it didn't know. Right, it was a shift reduce conflict because it didn't know if it saw an ID whether it was what kind of ID list it was, right? Or it needed to look too far. I don't know. Actually, I don't know how. I still don't see the conflict, but without understanding it completely, I can see how neglecting the parentheses could make it ambiguous. I just don't see exactly how. Restart the server. Server got really confused. Now it's okay. I think it's because op ID list could be unit or ID list could be unit. So it didn't know. Well, if you're parsing it as an op ID list, right? And it was that if it saw an ID, it was confused about how to, like, what its next intermediate step was, right? It didn't know whether to reduce it as an ID list using this rule. That's a reduce rule, right? If it saw an ID, reduce it as an ID list. Or a shift rule. I just don't see why shifting it would help. Maybe because it has to shift it and then look ahead to see if there's a comma or empty. And then it wasn't sure. But no, it has to do with this, right? Yeah, I just don't see it. I don't see it. Sorry, I don't see it. Okay. Crate ID. Oh, it's crate grammar now. Is that not a module? Oh, right, because we don't have that anymore. It's just ID list parser. Cool. So same error probably, right? It's just grammar. Which makes sense to me. Crate grammar. Comma. See, look, it's catching all my mistakes before I even run it. Okay, so yeah, I was expecting these failures because I wasn't exactly sure what kinds of errors we would get. So right param missing. I always forget which one's which. Left and right. What is left and right? Oh, I need to clean this up. Let's clean them all up. So from the top, right? All these just need to be outdented. Don't run the test. Misclick and I get it and actually runs the test. Sometimes it's neat, other times it's annoying. Yeah, so we got to be careful about the formatting in these macros there. Because Rust formatter can't help. So we got to go back to the old school way of manually formatting everything. Okay, it's getting to the point where I have to decide, am I going to be in person at my 10 o'clock meeting or am I going to call into it? If I want to be in person, I got to leave now. I could like be on my way there and then get there. I kind of rather call into this one because I don't think that I'm going to be asked to actually talk. And if I am asked to talk, I'll just say I'm in the car. Because I could still speak about the subject of the meeting and not need my computer. So that means my cutoff is really 9:30, so like a half an hour. Gives me enough time to pack up and go before I have to call in. Just let me double check. Yeah. Okay. I should try to end. I think what we'll do is I'll end the stream when I get this test running, and then tomorrow it'll be just now that we have all the grammar organized correctly or in a way that rules can leverage all the rules, then we just fill in the rest of the rules and we'll get our abstract syntax tree. Okay. Op ID list, right? Had a problem with So it's expected and then actual. Expected was that because we didn't know what to expect. And this is the r-paren missing. R-paren missing test. Okay. We didn't know what to expect, so I just put in plus. Actually, what we got was an unrecognized end of file. Okay, that makes sense. So we get an unrecognized end of file, and then that has a location. And then an expected. And then there are two things in there. There's comma and right paren. So that is the order in which we expect things, right? Or no, those are the alternatives we expect. We either expect a comma or a right parentheses. Okay, so let's run the tests again. Cool, so now we're down to 2 failures. So unexpected token inside list. Unexpected token inside list. So what we actually get is unrecognized token, right, giving us the alternatives again. So it's comma, and do I still have this in the clipboard? Yeah, I do. Comma and r-paren. And the plus is unexpected. Actually, we expect either a comma or a right paren. Okay, and the other one is outside list. It's unrecognized token. And here we expected a left paren. Okay, that makes sense to me. Cool, we're passing all the tests. Oh man. I like the fact that now it's not indented at all at the outer level. And then I have every grammar element has a test. We can still leverage all the things we're used to, like test cases and the lexer. I'm tempted to actually cheat and have these things, actually all of these things, just imported at the super level to clean this up a little bit more. Why don't we do that? So I usually don't like to do this, but for tests, I'm okay with it. We would just use super star, and at the tests here, we would do this. Why am I getting a error here? That's unused, but that's on purpose because I wanted to use them here. Because if I do that, it's an error, right? If I do that, ambiguous. Conflict between a name of a glob import and outer scope using. Okay, so I can't do that for test case because it's special. Okay, so and I actually got rid of the other problems here. So that, yeah, then I can get rid of this. This is this sort of boilerplate stuff I kind of don't want if I can avoid it. If I can just say use super star. Yeah, I think I'd rather do it that way. Hey there, shader kite. Prima generated me with 1,440 viewers, and I'm gonna get overwhelmed with chat. Oh no! Ah, run away! Run away! Run away! Run away! Troot! Hey there, everybody. How are you doing? I'm working on a parser. It's gonna be impossible for me to see chat other than the Rustin slides. I don't know if you know this, but I helped Prime actually make the Rustin slide. It's true. You can ask him. Not a lie. Not gonna lie to you guys. Troot. Wow. Okay. Do you guys want to see some actual programming, or should I just like do hot takes for the rest of my stream? Because I can't be here very much longer. I only got like half an hour before I got to go to work. I'm gonna not be able to keep up with chat. There's some amazing graphics in chat which I can't read because I'm looking at chat in a strange way. Is it making it look weird up there too? Yeah, look at that. You're totally like bugging out the stream parrot too. Do icy takes? Am I like the opposite of Prime? Am I the unprimeagen? Okay, I don't know. I don't know who's saying what because I just see a stream of stuff. Coding. Well, you know, what I'm trying to do is piss everyone off. So I'm going to say that I'm working on not GIF, not GIF, it's GGIF. We're parsing GGIF. See, I've now pissed off both camps simultaneously. Working on a tool that can parse binary data of any kind as long as you are Chad enough to be able to describe your format in my own language. I made this language. It's called the domain-specific language for the DataDisintegrator because that's how we roll. We take data and we disintegrate it. And then we like to look at all the little bits and say what they are. So, for example, I can go way back in the history and even further. Keep going. There we go. And it didn't work. It didn't work. Why not? Because we got a core dump because I screwed up the format. How did I do that? By putting a comma in here somewhere. Where was that comma? Let's get rid of that. Here it is. Get rid of that comma. Now this won't crash. Cool. So we actually have a GIF file, a good GIF file. Which Linux distro is this? This is not Arch, by the way. It is Xubuntu, running on Parallels VM on a Mac Studio. I can do this now. Look at this. That's right. We got reactions. Or I can just do a thumbs up and we get there it goes. Bloop. A little thumbs up. Yeah, when you're on a Mac, you get that for free. What powers the reactions? It's built into the latest Mac OS. Didn't you know? Anyway, my tool will take a lovely file like this GIF, which can't be loaded because it's broken. Let's try that again. Let's tell the thing to reload because it's being a pain. Because over 1,000 people are watching me, probably that's why. Why can't it load the worker? Come on, I want to see my lovely GIF. Reload. What do I got to do to see this lovely GIF? Okay, quit, VS Code, run, Vim, just kidding. There we go, we got a lull slide. I don't have a Rustin slide, I got a lull slide. So, that's how we see the lull slide. This is how the computer sees it. Like that. Now, if you're a computer, you see the blonde in there, right? If you're a computer. So, you can actually see some of this. There's the GIF. And there's the year in which the format was designed, which is in 1989. Not 1889, but 1989. So the tool I wrote is able to completely destroy that file and tell us that, hey, it starts with the signature. And then a version follows that. And then that's the end of the header. It's 8 bytes long. Then we have a logical screen descriptor. You can totally see that, right? That's got to be a logical screen descriptor because we got, I don't know, a comma in there, and then we have a 3, whatever. No, the tool is smart enough to use the format that I described, saying that it's a 300 pixel by 300 pixel GIF. If I scroll all the way to the end, the fact that it says 60 there means that there are 61 images, not 60, because we're counting at 0, right? Actually, I gotta do a backslash, and then I gotta do another there we go. Yeah, we start counting at 0, right? So 60 means that we got all the way to the 61st block. 61 images, and there's some other interesting things in here, by the way. When we completely destroy the lull slide, we see that there is a special purpose block application extension. Did you know that all GIFs have the word Netscape in there? And then there's a secret application authentication code. So we know that this is authentic GIF file because there's the secret code that everyone knows is 3288624 inside of a GIF file, right? 60 isn't the size, but the last element, yeah, it's the index of the last image in the GIF file. But there are things in here like, where is it? There's the delay time of 3. If you look at the ancient 1989 spec, it'll say that this number is the number of hundredths of a second in which to show this image before going to the next one. So that means it's a 33.33333333333333 frame rate, which means that the GIF is actually about 2 seconds long before it loops. But why make this tool? Because isn't it cool that we can like put on our parser glasses and actually see what the file means? If you're dealing with a binary format which doesn't show up as an image. So let's say a protocol stack, like you're running in Wireshark, right? You're looking at, you're hacking, you're doing your black hat hacking or whatever, and you're looking at a packet and you're like, what do these bytes mean? Well, someone's written the code that is just like my tool that takes these bytes and interprets them. And hey, we're looking at the address resolution protocol, okay? No big deal. And it's an Ethernet packet. The protocol's IP. It's got all these things. So you would use it in places where you can't actually visualize the data any other way other than taking the bytes apart and assigning meanings to them. So that's what my tool does. It takes apart the bytes of your files and assigns meaning to them. And the way it does it is you describe how to do it in this domain-specific language. So there we go. Can your tool defeat PDF? Yes, but you'd have to just define what PDF is. So the language I wrote is kind of like a combination between defining it as a data structure and having it as a function. And I hope that turned your brain upside down because that's the intention. This is describing the whole file of that lol slide as if it was a data structure. So it starts with a header, next there's a logical screen, and there's a trailer right at the end. But whoa, what the heck? We're doing a loop and we're doing a conditional. What are you doing? So this is in data formats where you have a repetition. You have one or more data blocks, right? The way you describe it in my language is you make it as if you were processing it linearly. You're saying like you're going to loop and you're going to have a data and then you're going to have another data and then you're going to have another data until you eventually break out because the next byte is a 3B, which means it's a trailer. And the way that it constructs the disassembled pieces at the end is this will be a part of a GIF, so a logical screen, and data will be a part, but it'll be an array. And it'll be an array of as many elements as we did loops. So that's why we had 61 of them. Isn't that cool? There's no way I'm going to be able to respond to chat. There's just too many. Chat, you're going to have to respond to chat. Can you save files with the 2? I mean, I could save this output to a file. Do zip files next? I could, but like, I gotta actually port this to Rust first. Oh, hey, Sean of the dev. Are you my new official chat responder? I mean, you do work for Twitch, so it makes sense that you would kind of jump in and help, right? Crap, we allow that word because that's a soft curse word. I need to tell AutoMod that crap is okay. Basically a programmable grammar, yes. It's a programmable grammar. Yo dog, I heard you like compilers, so we're putting a compiler in your compiler so you can parse the parsing. Basically, that's what I'm doing. This tool that is I'm showing the output now is written in C, and the front end of it uses Bison and Flex. So the original Lexer is a specification of regular expressions, and C code, which uses arcane words like y, it is taking the input, which is text lines with characters all the way to the end of the line for each line, and turning it into a stream of tokens. That's what a Lexer does. So I took this and I ported it to Rust using logos. So in my Lexer, it looks like, not here, it looks like this. So is actually pretty sweet. The Lexer and Rust logos is just a bunch of macros that you attach to your token type. So you define all your white space, you define all your character patterns, and then you go to it. So like you mark, here are our reserved words, and here's how you do a string, right? Of course, that makes sense. No, it's not a string, it's an identifier. Strings are actually down here somewhere because they're complicated. There'll be dragons in there. That's the kind of regular expression that's gonna make you wake up in a cold sweat in the middle of the night. But we got help from Philo and Philip on Stack Overflow to figure that out. Because strings are so complicated, we have special tokens for if you have an unterminated string or a badly formatted string. Like you started doing an escape sequence for an octal, and then you decided octal's 2 1980s for me. I'm just going to go hexadecimal. It's going to be like, okay, it's a bad string. Get out of here, right? But yeah, things like operators, super simple, right? Fun stuff are when we do like these different ways to say what an integer is. And if you've done programming before and you don't understand regular expressions, you can still kind of get it. It's like, well, we might have a sign bit, a sign character, and then we have a 0, and it might be lazy about if it's lowercase or uppercase b, but a b will signify it's a base 2, right? And we either have 0 or 1, repeat. Octals, same way without the b, but we have to have a 0 in front. Decimal is boring, and hexadecimal we have x in front, right? Floating point literals are interesting because you might have an exponent, you might have a sign, you definitely have a dot in there somewhere. So anyway, the Lexer is pretty sweet with logos because we're just annotating with regular expressions our data structure, and it does the rest. It's super cool. The hardest part was to figure out the regular expressions. Did I start in 1980? Yeah, I was on an Apple II. Yeah. I was making little text character games. And then I would get this from my dad when I would get it to work. Well, you don't have the letter O in octals? No, you don't need that. That's too much characters for me. I don't roll that way. Basically, if it's a 0 and then it's not a B or an X, it falls into the trap of being an octal. Roguelikes? Yeah, like the original Rogue. Only that it would just play through once and you had no control. It was basically a sequence of lines in Apple Basic, which it says print this text and then go erase it and then print something else and then go erase that and print something else. It was pretty sweet, I thought, for being a little youngster, you know. Okay, chat is starting to slow down, so maybe I can answer some questions besides starting in 1980. Yeah. There's more than one reason why I got white in my beard. Why is everything in my taskbar blue? Which taskbar? You mean when I'm highlighting? Or do you mean down here? I like blue. I mean, blue's a sweet color, don't you think? Would this be easier to implement Serif using a custom Lexer? Yeah, but I don't know. I thought it was kind of boring, to tell you the truth. The most exciting thing was escape sequences and strings. But yeah, anyway, that's all old school. If you want to go watch what I did for the Lexer, go to my YouTube where I've archived it. Just look for stream number 6 or 5. I can't remember which one. The title will say that we're doing the Lexer. Anyway, the next stage after a Lexer, if you want to take this and actually do what I did with it, is you get a token stream out of this, right? You get things like, actually, I can just show you that. Let's look at the token stream. That's the wrong thing. I don't want to parse it. I want to run lex, actually. Not less. Not the less. No! No! It's target. Oh, have we not run this? Oh, okay. I might have to do cargo run, and then I gotta do a project lex, or is it bin lex? Yeah, and then the path, which is stage gif.form. There we go. So here's the token stream that we get out of the lexer. Identifier, gif, left brace, identifier header, semicolon, identifier logical screen. So that's basically that. That's the first stage output. We've like chewed up the program, but we haven't swallowed it yet. So the next stage is we have to parse that and see if it matches the correct grammar, and then we form the compiled version of this file, right? And that is done by the parser generator. So back in 5 years ago, when I did this in C, I did it in GNU Bison, which is a clever play on Yak, which is a really old, yet another compiler. And why am I pointing it to Rust? Because, I mean, don't we all port stuff to Rust these days? I just like Rust. That's the only reason. So the original grammar is specified in a language that Bison accepts, which is called a Bacchus-Nor form, which is another ancient computer term invented by graybeards, where you basically describe a language in terms of pieces that you fit together from left to right, and they can reference each other in exotic ways, and then it becomes impossible to understand. But maybe not too bad if you look at, like, you can kind of see patterns here, right? A format, of which this is an example, is an identifier with an optional list of identifiers after it, with a left brace, some statements, and then a right brace, right? That's not too bad. Here's our identifier, here's our left brace, here's our statements, here's our right brace. The rules build on each other. So format leverages statements. Statements leverages statement, singular. Statement has a body. Statement body has, it can be a part, or it can be an ignore, or it can be an if statement, it could be a for loop, it could be a while loop, all sorts of things, right? So that's what we're looking at when we look at these individual lines. These are parts of a GIF. Here's a local variable declaration, here's a loop. So they can be compounded. A while loop can have a block of statements in it as well. You get the picture, right? You'll use BNF for generating railroad diagrams to more easily visualize how it works. Hey, you know, it's a very flexible way to describe any kind of things, so why not, right? Domain specific language, that's what this is. So did the lexer a couple days ago, doing the parser today, and probably for the next week or two, because there's a lot of grammar in here to get through. It's literally like 1,000 lines of grammar. It's more than 1,000 lines. It's down to 1,131 lines, almost as many people as rated me. So that means that every one of you raters is assigned one of these lines in my grammar, and I expect that by 1 week from now, you'll come back to me and given me the Rust equivalent of that. And hope to God that you are assigned one of these lines and not one of these lines. Anyway, porting this to Rust, I picked the Lollipop for crate because it's just such a cool name. We have to use it, right? It's such a clever turn on words. LALR means look ahead, left to right, which is a traditional parser generator. So if I go to like search engine, I do Lawler. Hopefully I don't get a weird image. Yeah, Lawler parser. Look ahead, left to right deviation parser. Maybe it's not a deviant parser, hopefully. And then because Lawler sounds like lolly, and why not put a pop on the end and call it Lawler pop. So the way that this works, that I'm learning still, because I didn't know anything about this a couple days ago, is we define our grammar kind of like the way we did with Bison, only it looks a little bit more rusty. And we kind of mix Rust code and we say, oh, now we're not in Rust anymore. We're in the special Lollipop language, which kind of looks like we took the Bison and kind of let it sit for long enough that it rusted. And then we have an epilogue, which this is how we glue into our lexer. We say all these things actually have these Rust types that we define in our lexer. If you remember, I was showing the token.rs. It had like enum token, and it had these things like, well, down in here somewhere, there's like plus, right? And in my grammar, I got a plus. The only thing kind of weird here is that for some reason they want me to put Angle brackets, I'm not going to judge. So it's not exactly Rust. It looks weird, but that's what they want. So that's okay, right? I have to remind myself this is not exactly Rust. This is Lollipop Rust. And that's how they roll. Is this open source? My stuff is only open as far as you can watch me do it on Twitch. Lollipop is open source, though. Have fun with that. I wish I could make my stuff open source, but that's one of the conditions of my job right now. I can't publish anything open source without getting like a super amount of bureaucracy, and it's just impossible. So I content myself with showing you what I'm working on in my spare time on Twitch, and sorry I can't check it into GitHub. You like Pest even more than Nom? I asked ChatGPT this the other day, what should I use for converting my parser to Rust? And it said Nom. And then I said, that's a stupid answer, so tell me again. And it said Lollipop. And I said, better answer. I didn't pick Nom because I'm using a Lexer and I don't know how to I don't know how to connect Nom to a Lexer. It looked like it wanted to do the Lexing also, so it didn't look suitable. Is this work stuff? No, this is not work stuff. I'm not allowed to do work stuff. I don't do Rust at work, so at my spare time, I do Rust. Kind of job does not allow you to contribute to open source. A job where when you are being interviewed and they say, this is a great job, but you won't be able to do open source, that kind of job. The companies are weird. Sometimes they just say, hey, we're kind of nervous about conflict of interest, and you can't do these certain things. I'm like, okay, fine. Yeah, a lot of them, sadly, yeah. Can't talk about it. That's one of the rules. I can't really talk about work. So hey, let's talk about something else. How's the weather? Just kidding. So I have 4 rules of the grammar done so far, and I have a whole bunch more, and I don't have enough time to do them today. But I want to give you a sense of what you might see me do if you come back tomorrow. I have to end soon. What else can I talk about? I can show you what I've done for testing this. I'm trying to stick with test-driven development, right? So, I can delete these old files. We don't need them anymore. Let's delete them. Goodbye. Delete you. We don't like you. Goodbye. You and you. Goodbye. All right. So we have all our grammar in one lollipop, and then we have this pulled in at the top level by doing this utility that Lollipop provides called a Lollipop mod, and we do that as a macro call, and we say, look at our grammar, it's wonderful. So it's going to pull in grammar.lollipop using this really cool macro. All right, so how we test it? I decided to stuff all my tests in a mod test and say only build this for testing, right? Otherwise, stay away. In tests, we're actually decided I'm gonna break up my tests into 4 modules because I'm gonna try to keep it clean, right? I'm gonna have 1 test file per grammar rule, and that way we're testing grammar rules as units. So instead of testing all the grammar at once, we're looking at a microscopic level. All the tests have some common boilerplate, so we're just gonna put it here, and then we're gonna be a superstar at every sub level. That lets us pull in the common boilerplate here so that they can give us a parser error. And by the way, here's how we connect to our Lexer. We're using our Lexer's error and token types. Pretty slick. So I am leveraging a crate called test case, which is really super awesome. I didn't know about this until last week, in that I can describe a function that is a prototype for a whole sequence of tests. So given some input and some expected output, run it through the parser for an ID list and see if we match. And so I'm like, okay, well, we might have 1 identifier or we might have 2 identifiers. So if we have 1, this is what it looks like, and this is what we expect the parser to give us. Sweet. If we have 2, then we're going to have a comma between them, and then we're going to get 2 things. That's also cool. But what if we have too many tokens? What if we just threw in a plus there? Well, the parser is going to barf and say, hey, I don't recognize that plus. Get the hell out of here. Too many tokens. Then we have an unrecognized token. It's like, this isn't an ID list. Totally don't accept that at all. We accept comma and we accept ID. That's all we accept here, right? And I have like you should always have the corner cases like, no, I don't have anything for you. There's no IDs at all. So that's okay, fine. Then you get no output, but it's still okay. We're cool. So I have that for every grammar rule. So there's optional ID list leverages ID list by saying like, you either don't have one at all or you have some list. And the way we distinguish an optional list from a list is that we put it in parentheses. So if it's in parentheses, then it comes out as an ID list, as some ID list. Otherwise, it's nothing. And if you don't have a left parentheses or you don't have a right parentheses, you get an unrecognized token error, basically. All right. Oh yeah, before I leave, if you want to learn compilers like a true graybeard, this is the book for you. This is what they call the Dragon Book. Compilers, principles. It's so old that the picture of it is blurry. That's how old the book is. But I've heard that there's a second edition of this book. But look, you can learn about Lawler parser generators. And look, there's syntax-directed translation and data flow analysis. Look, it's not just an epic scene of a knight versus a dragon. It's the complexity of compiler design is being battled by data flow analysis, parser generation, and directed translation. This is an awesome book because it basically explains in approachable terms everything I just said in the last 15 minutes. So I know you want to buy that book. Maybe the second edition, I don't know. It's probably $90 because this is the original and this is such a popular book that if you were to buy it from me, you'd have to pay me $1 million because this is the one book I'm keeping from my college days. Basically, that's going to run you through how to do old school parsing and lexing using tools that like they're so old that they're not even syntax highlighted. That's how old. I'm just kidding. The original Bison and Yak, right? Or I should say the original Yak and Lex. So we're talking like AT&T, IBM day tech. All right. That's just about it. Tomorrow we're going to be adding more grammar rules to the grammar. And then every time I do that, I'm going to add another module for tests. And my goal is that by the time I get to the end, I'll have the entire grammar converted to Rust. Once you get the whole grammar done, then going back to this, what we can do is this gets compiled into what they call an abstract syntax tree. Basically, it's a digested form of this that the computer can like walk through in a certain order and match it up with, again, the bytes from our input file, which I closed. But if I were to open it again, the computer, again, does not see it like that. The computer sees it like this, right? We're going to, starting with the very first byte, walk through with two hands. One hand is looking at the bytes. The other hand is looking at the abstract syntax tree, and we walk through them together to get what I got when I ran this, right? These characters from the input file matched the very first thing in our abstract syntax tree, which is the beginning was GIF. At the beginning of time, there was GIF. And then at the GIF said, there shall be a header. And then the header said, there shall be a signature, B. And then everything was good. And then there shall be a 24-bit version. And that was good. And then we rested on the 7th day. Now imagine HTTP like this. Open-ended formats are a little bit more difficult, but this really works well with protocols. So again, something like Wireshark, really, really easy to describe these elemental data formats because it's literally just a list of things like hardware type, hardware size, protocol size. And by the time you get to the last byte, you're done. And you're like, that was easy. I want to give me another protocol, man. That was super fun. Who is Jeff? Jif, the sister of Jeff. We could say good Jif, and then I could piss off everyone. So yeah, my goal is once I get all my grammar rules converted to Rust, I should be able to first get the abstract syntax tree and then use it to actually parse real files. By the way, the abstract syntax tree, I'll show you what it looks like here. So this is what the, if I do a less, so we can see it from the beginning. I think what's actually happening here is it's sorted it. So I have to look for GIF in there. Yeah, here we go. So kind of showing that side by side, if you will. Maybe make this a little taller and then maybe do that. You can kind of see this looks like a digested form of this. This is, again, just a text representation of a data structure in memory. But roughly speaking, it's a tree. So at the root is GIF, and then there are 5 children, 5 child nodes. There's header, which is a part, logical screen is a part, and then a local variable statement, and then a loop with a condition of 1, which means always. And then inside of that, there's a subtree, right? That we could go into if we wanted. In fact, we will, because the rest of it's just trailer. Inside the loop, we have this ignore statement, and then this conditional, which has the condition, and then inside of that condition, there's a break. You might be asking, why did I make the if another level? And that's because we might have an else. Haha! So we might have another child called else, but we don't. So you kind of get the idea. I want to have the Rust version of this build the same abstract syntax tree, and that'll be basically a big Rust data structure, right? With boxes, and it'll be fun, right? And then we'll use it again to actually parse real things, which looks like that. So after I get that working, then the real fun starts, because it's super boring to look at this in the console only. I want to write a user interface with a nifty window and have it show the tree in a GUI and be able to like collapse and expand different nodes. And I kind of want something similar to Wireshark, where you can just show the bytes and then I click on a byte. I think it's super awesome to be able to click on a byte and it shows you what that byte means. You can do that in Wireshark, and I want the same thing for my stuff. And then to go beyond that, wouldn't it be cool if the GUI highlighted in red the parts of the file that were bad, like corrupted, and let you go fix them? Or what if the tool was smart enough to say, this next byte should be an FF, but I saw an FE. Let me just change it to an FF and see if it works. And oh, wow, it works. So automatically repairing corrupted files. Wouldn't that be sweet? So yeah, those are my end goals of this project. I don't know how long it'll take for me to get there, but I gotta go to work now. I don't know what to say other than I got work to do. So let's go watch something fun. How about we go watch scammers getting scammed? You guys know Kitboga, right? We're gonna go raid him. I hope that you thought my project is cool. If so, please come back tomorrow. As long as Primogen isn't streaming, other way around is we might raid him tomorrow if I finish first. Otherwise, yeah. Hope you had fun. I'll be working on this for a while, probably the next couple weeks. So drop in anytime you like. Okay. See you later. Enjoy Kitboga. Bye.
Kitboga scams Kitboga.